Assalamu alaikum. This is Khurram Shazad from XII Academy Senior Campus, Kushamala Kent. I welcome you all to FBISE online sport program. I'm here with this sixth lecture, which is the last lecture of the week and last lecture of the chapter. Also, this chapter is basically based on the advanced concept of an operating system. In this lecture, we will do the revision of the last lecture, then we will discuss what is thread and process and what is the difference between a thread and the process. Then we will discuss what is multi-threading, then we will discuss what is multitasking, then multi-programming, and then I will assign you some questions and you have to answer this question before the lecture ends. So let's get it started by last lecture revision. Last time we have discussed that what is a process. I have a very simple word that a process is a program in a running state. A process is a program in execution. Any process which is executing on our CPU, on our computer, are using some kind of resources of our computer system. For example, it uses some amount of RAM, it uses some amount of processor and some other resources. If the process is internet based, then it will use the internet resources too, and if it is a camera application or printer application, it will use that resources too. Any process which is executing on our computer are using some kind of resources like CPU, RAM, etc. So there are many different stages of a process. For example, when we launch a process or when we double click and open a program, it will wait until the RAM allows it to load into itself. When the RAM admitted that this program is very good to execute, then it will wait in a ready queue and it is in the RAM. When the program is successfully loaded into the RAM, this process is called the loading. The loading has successful. Now it will wait for its turn to get the CPU. When the CPU is free and this process is dispatched and sent to the processor, it will be called a running state of this process. And if everything goes successful, then it will a normal success exit, it will be called terminated. But not every time a process successfully exited. Sometime there may be problem. For example, if a process is using some camera and the camera is not attached or not available yet, then the process cannot continue its processing because it requires a camera to complete its working. So it will again go to the interrupt, and interrupt will be occur and the process will wait in a ready queue again to be camera available. Until the camera is not available, it will wait in this queue, and when the camera is available and the CPU is free, then it will again dispatch to the running state. And if a process is a multiple of some other process or a conflicting process occur, conflicting means a process is conflict with another process, one process is blocking an other process. In this scenario, when a running process is blocked, it will be called a block state. A process is blocked and it is saved in a blocked queue. And when the CPU is free and the program which blocked that process will unblock the process again, and it will again wait in the ready state in the RAM, and then it will be sent to the processor and it will be in running state. Then it will be safe exit and it is called the terminated state of a process. This was the revision of the last lecture. Now we will start our today's lecture, which is thread and process. In a programming language, a process is simply a sequence of instruction for the computer to be executed. But not all the instructions are coded at one place, they are coded in different threads. A process may have many threads. For example, I'm talking very simple about a media player, which is a VLC media player. You already familiar with this kind of software, which is a multimedia software which is used to play audio and video songs and movies, etc. There are three main threads. For example, we are discussing it as an example. When we open the media player, it is the responsibility of that specific code to open the media player and display us an interface of the media player. The only one T1 means the thread 1 will execute and it will open the VLC media player. Now the next thing is, who is responsible to load the program into this? And when we select a song and hits the play button, then another thread will be responsible to play that song. And when we add another song, then another thread will handle that song too, or will handle the playlist too. And all these things will be done in a single process, which will be called VLC media player process, and all the process is executed by a CPU. T1, T2 and T3 are the threads in a process. So in programming, there are two basic units of execution: processes and threads. They both execute series of instructions. A process is an instance of a program that is being executed. A process may be made up of multiple threads. In particular, a process may have many threads, but it is very mandatory for a process to have at least one thread at a time. Now we will discuss about thread. A thread is basically ordered sequence of instruction within a process that can be executed independently. The threads are made of and exist within a process. The threads are made of a process and exist and only exist within a process. A thread may not run independently. They always require a process to run it. Every process has at least one thread. Multiple threads can also be exist in a process. A process may have multiple threads, or it is mandatory that it is very necessary for a process to have at least one thread to be executed. Now again, in this diagram, when we have a single process which is VLC media player process, and there are 3 threads, and there may be many more threads in this software, but we are discussing about 3 threads. Now I will show you in the real time what is the thread. I have opened nothing in my computer. I'm on Windows 10 latest version. I have opened some programs and I will show you that what is a thread. Now I have opened Microsoft PowerPoint, which is only a single program which does not have any other thread, but some of the process have many threads. For example, I'm using a PowerSoft Screen Recorder Pro version. This is a single process and may have multiple threads. This process is using my 90% CPU, 37% of RAM amount, and this is not using 0.1 MB per second. Now I will show you what are the threads. They are the thread actually running this recording form, the main form which is responsible to record the whole screen, and a time duration counter or saving counter which is sim. And Microsoft PowerPoint have also another thread. For example, I have opened 2 things. I have opened a slideshow and a slide in my PowerPoint program. So this main thing is called the process, and within a process the 2 things are called the thread. Now go to further. There is a difference between the process. For example, a process, an executed instance of a program is called the process. A thread is a subset of the process. This is a simple definition, but there are many technical things differ with each other. It has its own copy of data and segment of the parent process. A process may have its own copy of data, and all the data and the space is owned by a process whole. It has direct access to the data segment of a process. Now, third point, any change in the process does not affect other process. Any change in the process does not affect any process. If I close VLC media player or PowerPoint or screen recorder, other process will not be disturbed. But if I change a single thread in a process, the other threads in the process will be disturbed accordingly. Processes run in separate memory spaces. Threads run in the shared memory space. All this space is required by a process is occupied by a thread, and it is shared by all the threads. I will show you again how does it share the space. For example, I've opened the task manager. The task manager showing that a PowerSoft is using 91 MBs of my space. But if I scroll to the threads, they are not using any kind of space, but they are using the space occupied by its parent in a shared form. Both are sharing this 92 MB space of the program. So thread may not have their own memory space, but they share the space occupied by a parent process. Processes is controlled by operating system. Process is controlled by the operating system. Threads are controlled by the programming in the program. Processes are controlled by operating system because all the process operating system is responsible for the management of the process. This is a basic function of an operating system, but it is not a function of the operating system to control the threads. Processes are independent to each other, but threads are dependent on each other. For example, we have discussed the VLC media player example. If we doesn't execute process 1, for example, in this there are 3 threads in a process. If I cannot execute this one, I do not open a VLC media player, will I be able to play some song? I have not opened the media player, so I'm not able to play the song. I'm not able to add the song. I'm not able to play, pause the thing. If thread 1 is executed, then only thread 2 will be executed. So these 2 threads are dependent on this one thread, which is open VLC media player. So our last point is very correct, that threads are dependent on each other. If one thread is not executed, maybe other threads will not be executed until that thread is executed. For example, in the ATM machine, the first thread is manage our card. If we don't insert a card, we cannot do anything. Other threads are unable to use. Other threads cannot do anything for us without inserting a card. And if we don't enter a pin code, then it is very simple that if we not enter the code, it will not do anything for us. Now I will discuss about multi-threading. Multi-threading means executing multiple. An operating system is unable to execute multiple processes on a single computer CPU, but multiple threads can be executed on a simple CPU. For example, I have the main code which includes many threads, thread 1, thread 2, thread 3. All these threads can be executed simultaneously into a computer system. We will discuss it in detail. The process of executing multiple threads simultaneously is known as multithreading. This is the definition. You have to remember that the process of executing multiple threads simultaneously is known as multithreading. Multithreading is the execution method of a program that allows single process to run multiple threads at the same time. Multithreading allows multiple threads to exist within a single process, and these threads can execute independently. The main purpose of multithreading is to provide simultaneous execution of 2 or more parts of program to maximum utilize the CPU time. our CPU has a very fast time. Our CPU can process millions of instructions per second. So if we execute only a one thread on one processor, it will execute in a very quick way. It will execute this thread very quickly, and rest of the time it will be free and idle. So we have to make our CPU to busy in some process. So we will execute all the threads simultaneously by this time. For example, it is very simple to give the example of a bus. A bus have a very large capacity of transferring passengers from one place to another place. So if we fill our bus with all the passenger, it will take all the passenger to the destination. But if we fill only one passenger into the bus, it will take the same amount of time, but the output will be very shorter and our cost will be very high. So our CPU have a very large amount of time. It have a very quick processing speed. It can process millions of instructions per second. So we have to utilize it maximum. Some example of multithreading. Multithreading means this is a very simple example of MS Word. A user is typing a paragraph in the MS Word. We are typing a paragraph in MS Word, but in the background one more thread is running and checking the spelling mistake. You have never noticed that when we type anything foolish in our Word document, it will notify us in three ways. It will make that paragraph red line, and it will say that there is a spelling mistake. It will make our underlining green, and it will say that there is a grammar mistake, and it may also be underline our paragraph in a blue way. So we will notify that we have a punctuation error. So one thread is responsible of typing in MS Word, and in the background another process is running and checking our spelling mistake. As soon as the user doing a typing work on the other threads notifies user about the spelling mistakes. So this is a very simple example of multithreading. Another example, web servers uses multi-threading all the time. Every request is handled by different threads share resources. In web server there are many websites and many threads are running. For example, if you have a website, your website may be viewed by millions of the people at the same time, and our website is only stored on a central system or only a single system. Then how can multiple users access that website? This website is accessed by multiple users by using thread. If one user is viewing our website, it is working in thread 1. If other user is browsing our website, it will be on another thread, and all the user may have different pages open in our website. So web servers always use multi-threading all the time, 24 hours and 7 days of a day, because a website is live forever. It cannot stop in any way. So web servers uses multi-threading to provide their user the ease of access time. Now I will discuss about multi-programming. Multi-programming means many programs are loaded into the CPU, but the CPU is not enough powered. It can execute only one program at a time. In multi-programming, many program loading in, for example, we are loading the Word, email, web browser, 3 programs into our operating system. Our operating system understands that our CPU can execute only one process at a time. So it will make all the process in a queue, and it will execute all the process turn by turn, and the CPU will execute all these things very quickly. We never notice that these execution were on time by time or turn by time. For example, when the user loads a program we may say MS Word, and program 2 we may say C language compiler. The CPU is able to execute only one program, for example MS Word or C language compiler. Both are not, or both cannot be run simultaneously, but only one. So our operating system will manage all the things by multi-programming. It will program our operating system and execute all the programs turn by turn. It will execute first 1 second of one program, another second the other program, and we will never notice that this processing was done by turn because of the processor speed. The advantage of the multi-programming is that it saves users time in loading the program into the main memory and run the program quickly. The only drawback is the system requires more main memory as it is occupied by many programs. Sometimes bigger program cannot fully load it in the main memory, and thus the program runs slowly and our computers hangs or held on that space. So multi-programming is a process of loading all the program into the main memory and executing them turn by turn on a single CPU. Not every time we have a limited CPU. We have a bigger system, we have workstations, we have server computers, we have supercomputers, mainframe computer, mini computer. They don't need to only use one processor, they use multiple processor. Multiprocessing is the ability of operating system to execute more than one process simultaneously on multiprocessor machine. Multiprocessor machine having a machine more than one CPU. For example, in the Google and in the Microsoft, the system are using thousands of CPU. If one CPU is out of order, the other will take the processing. In a multiprocessing environment, everything runs smoothly on multiple processor, multiple RAMs and multiple hard disk drive. All the things are shared, and if one thing, for example one hard drive is out of order, the other will replace that gap. In multiprocessing, it is the ability of an operating system to execute more than one process simultaneously. Simultaneous means at the same time on a multiprocessor machine having more than one. In this a computer uses more than one processor. For example, I have a computer which have 4 CPUs. I'm not talking about the quad core CPU or quad core processor. These are only one CPU. I'm talking about multiple CPUs. There are many generations of the computer, for example Core 2, Core 2 Quad, i5, i7, i9, but these are in a personal computer environment. These are PC processor, they are not workstation processor. In the workstation there are multiple of that kind of processor attached in a RAID order, redundant array of independent disks. They are arranged in a sequence in a very parallel order, so they can process all the things simultaneously. For example, if we have to process 4 processes and we have 4 CPUs, we must simply attach process 1 with the CPU 1, process 2 with the CPU 2, process 3 with the CPU 3, and process 4 at the CPU 4. So all the thing will be done simultaneously, and we have not to wait very long time for the processes to process turn by turn. That was our today's lecture. I will make you a quick summary of the lecture by table of contents. For example, we have revised the last lecture. We have discussed threads and the process. A process is the main part and the thread is a part of the process and have shared space. Process have a full space and thread have a shared space. We have discussed multithreading. Multithreading means executing all the threads or multiple threads on the single process is called multithreading. We have discussed multitasking. Multitasking means doing many things on a same computer or executing multiple programs on multiple on a single system. We have discussed multi-programming means loading all the program into the RAM and executing all the program turn by turn. And we also have discussed that wait we have already discussed that multiprocessing is the ability of operating system to execute more than one process simultaneously. Now I have a short assignment for you. You have to fill up these questions and send me before the lecture over. First question is, what is a thread? What is the difference between multiprogramming and multithreading, by giving the example of each. Explain multiprocessing. And the last question is a logical question, how multiprocessing is used in our daily life. I suppose I have already discussed in my lecture, but if you have listened my lecture carefully, then only you can extract this point, or you may search out something about this question and you have to answer this question mandatory, and other questions are only the bookish questions. So thank you very much for this lecture. You have to do a quick reading from the book too. I am uploading the book with the lectures. Thank you very much. Allah Hafiz.